Dear viewers, I welcome you all for yet another lecture session on the topic mass spectroscopy. So, mass spectroscopy is one of the primary spectroscopic methods for molecular analysis. It is a microanalytical technique requiring only a few nanomoles of the sample to obtain characteristic information with pertaining to the structure and the molecular weight of analyte. It is not concerned with non-destructive interaction between molecules and electromagnetic radiation. Thus, the mass spectrum of each compound is unique and it can be used as a chemical fingerprint to characterize a sample. Coming to the principle, mass in this technique, in this mass spectroscopic technique, molecules are bombarded with a beam of energetic electrons. And this bombardment of molecules causes the molecules, they will be broken up into many fragments, some of which are the positive ions. And each ion has a particular mass to charge ratio, has a particular mass to charge ratio. And this mass spectra, those particular mass to charge ratio, and this in this mass spectrum you will have in the x-axis you will have mass to spectrum ratio, and in the y-axis you have relative abundance of the ion. That gives a mass spectra. So this mass spectra is how it is useful. It is used in two general ways. One, it is used to prove the identity of the two compounds, or it is used to establish the structure of a new compound. So how to establish the structure of a new compound can be done in several different ways. One thing is, it can give the exact molecular mass, or it can give a molecular formula, or it can reveal the presence of certain structural units in a molecule. Coming to the construction and working, and what is the instrumentation part in this molecular spectrometer, we'll have a look into this. So generally the mass spectrum, it is the plot of relative abundance of ions against their mass to charge ratio. So as we have seen earlier, you have high energetic beam of electrons, and these beam of electrons which is accelerated from a filament to an energy of 70 electron volts to form positively charged ions. The additional energy of these electrons is dissipated in breaking the bonds in the molecular ion, which undergoes fragmentation to yield several neutral or positively charged species. This fragmentation may result in the formation of an even electron ion and radical. The various positive ions thus formed can be accelerated and deflected by magnetic and electric fields. The deflection of these ions, however, depends on its mass, charge and velocity. For a given charge, velocity and a deflecting force, the deflection is less for a heavier particle as compared to that of a lighter one. Thus, the number of beams, each containing ions with the same mass by charge values are obtained. These beams are then made to strike against a photographic plate, where these beams, they not only appear as straight lines, but the intensity of each peak is also recorded. Thus, the clear visual representation of a mass spectrum is usually obtained by plotting the mass by charge ratio value against the relative abundance, assigning the most abundant ion in the spectrum is 100%. And this is the block diagram. This diagram represents the different stages of a mass spectrometer. The first stage is the ionization stage, next is the acceleration part, followed by the deflection stage, followed by the detection stage. We will cover each and every stage in detail now, how ionization happens. So the vaporized sample, when it is fed inside this ionization chamber, you have an electrically heated coil is there, which ionizes these atoms, and thereby it kicks off it ionizes the atom, thereby it kicks off one or more electrons out of the sample, thereby positive ions will be formed, and these positive ions are persuaded out of the rest of the machines. These positive ions are persuaded out of the rest of the machines by an ion repeller, which is another plate carrying a slight positive charge. Next comes the acceleration stage. These ions are accelerated so that they all have the same kinetic energy, and these ions are accelerated by these plates, three slits with voltage in a decreasing order, and all these ions are all accelerated into a finely focused beam. Next comes the deflection part. So can you see here, you have an electromagnet around this tube. So the ions are deflected by the magnetic field according to their masses. Lighter the mass, more the deflection will be. So can you see here, this is ion stream A. Since it's heavier, its deflection is less, whereas ion stream C is light in weight, in mass. Hence, it is being deflected. The deflection is more for a lighter ion. That's how you have only ion stream B, which is leaving out of this deflection stage. Next, this ion stream B will enter into the detection stage. Just see. So this is the detection part. You have an ion stream B, which is coming out of that deflection stage, and when this ion hits this metal box, its charge is being neutralized by an electron which is jumping from the metal onto the ion. So that leaves a space among the electrons in the metal, and these electrons in the wire shuffle along to fill it. So what happens, there is a flow of electrons. These flow of electrons is detected as an electric current, which can be amplified and recorded. So thus you have a mass spectrum which represents, in the previous slide we have seen that you have the mass spectrum which represents the m by z value against the relative abundance. Hope you find this video useful. Thanks for watching.